Hey guys, I won't be recording my face today. Uh, After the last discussion on linear regression, I have just created some uh, basic code for the decision trees and logistic regression. I've coded it earlier as a practice. Uh, I'll be going through it right now and explain it to you guys. I didn't get the time to record it because in weekdays it's a bit difficult to record. So I'll share it right now. So in logistic regression is it's basic. I won't go how the gradient descent etc. The graph looks like, because I went through it in the linear regression part. Right now I'll just show you guys how what's the basic difference. So the basic difference is this simple thing. It just in logistic regression it adds the non-linearity to the code. Up till here it's linear regression. We get this output and we perform the weight updation and all. But here we pass it through our sigmat function. We get the prediction over here. It will be between 0 and 1, and basically the probabilities. And then this weight updation will keep on happening. We'll get the new weights and biases, and prior to that, in case of prediction, what we'll do is say in definition of predict, we'll pass in the row, and then we'll just do and the weights and biases that we'll have here. In the end we'll get this. And then we'll add the bias, and then the prediction will be this. Sigmoid of, that's it. So this will give us the prediction of the logistic regression that we have. Okay, so decision tree is a bit quite interesting. I did this today morning only. So first of all I'll just share some things that I followed, the steps that I followed. I did not go to the deep how I did it, but just the overview that I wrote for myself, that you guys also should write before going to code. First of all, get the features and the individual data, and then identify the best features for the split, and you will use Gini for it. So decision tree, the main part is this portion only, so we'll focus on that. So first we'll go here. So what happens is that in this code basically we're trying to get the feature with the best Gini, and we'll use that feature and the threshold through which we got the best Gini and split it, and this loop will go on. This particular loop will go on. First of all, we get the number of features by getting the length of x0. We can also get it by x dot shape, but no issues. Then we keep a counter for Gini, just to keep in record that okay, which one we'll be taking. And then we have for each feature in the basically we pick the IDs of the features, and then we try to get that we try to get the unique values. What I mean by that is that suppose in this column, it's a numerical column, we have unique values, all are unique values, but suppose we have values like 1 2 3, and 1 2 3 continues on, is the basic value of that feature, then we select those unique values. If it's categorical, we select those unique categories and transform it to numerical by one hot encoding, and then we select all rows of that particular feature. So this is NumPy thing that we're doing. This is for the row and this is for the column. We select all row for that particular column, okay, and then we also get the parent Gini for identifying the information gain. So this will be information gain. I named it as final Gini. And for each threshold, all the unique values that we have, what we do is that we get everything that's below that particular threshold for our right values, and similarly for the left, and the rest for the left. And then what we do is that we get the y values for it. Why we get the y values? Because for Gini we have to use the y values for that. Alright, so we get those values, and for that we calculate the particular Ginis of the right tree and the left tree, and then we get the weighted Gini, and then we subtract it with the parent one, and then we keep on checking if that Gini is the best one or not, and accordingly we update that value and return it. So this will be the one. This will be the basic thing of decision tree. And for Gini, what we do is that we get the unique classes of y. The thing here I am doing is decision tree classifier. Okay, for regression we have different things. This is for decision tree classifier. We get the denominator. Basically we have to I'll assume that you guys know how we calculate the impurity, the Gini impurity. We subtract 1 from the square of the probabilities of each unique classes. So for that we take the unique classes, we keep the denominator here, impurity we kept it as 1 so that we can code it out here like this. So basically for each classes we get the probability and then square it out and then subtract it with the 1, and then we return the impurity of that particular a class. Okay, so this is it. It's short, but the main criteria for these videos are obviously I get to keep a record of my practices, and secondly you guys will get the idea that how to practice such algorithms, and it will basically help you to, even if you in future you wish to switch to business, you will have these things in your mind, and for your business too you can apply these things, and you will obviously be ahead of the others. So yes, you guys also should practice these things. This will be it for my side today. Bye.